Welcome back to The Explainer. Today, we are diving headfirst into something truly wild. It's a theory based on a paper by independent researcher J. Alfred called Earth's Dark Plasmaspheres, and it proposes something, well, mind-bending, that our world has an invisible twin, a dark planet existing right here, right now, completely surrounding us. Yeah, let's get into it.
So let's just start with the big question. What if the Earth we see, the ground beneath our feet, isn't the whole story? What if there's another, much larger world interpenetrating our own, a vast, invisible structure made of dark matter? And no, this isn't the latest sci-fi blockbuster. This is a serious theoretical model, and we're going to unpack it piece by piece.
All right, so here's our roadmap. First, we'll talk about what this invisible twin even is. Then, and this is the really juicy part, we'll go through the case for why it would have to be made of plasma. After that, we'll look at its structure, how it might form nested worlds, and finally, we'll get a sense of just how massive this dark neighbor of ours could be.
Okay, part 1, Earth's invisible twin. Let's lay the groundwork for this whole idea. What exactly are we even talking about? The basic idea is a dark Earth. It's a planet-sized body made of self-interacting dark matter. Now, the key thing to get your head around is that it's not hiding behind the moon or out past Mars. The theory says it's in the exact same space as our planet, spinning right along with us. And maybe the most important part, it's not made of dark rocks or dark dirt. It's a gigantic sphere of plasma. Think less of a planet and more of a tiny, invisible star that we're living inside of.
So that brings us to the absolute heart of this theory. Why plasma? I mean, why wouldn't dark matter just clump together to form dark atoms, dark molecules, and eventually dark mountains? Well, the author lays out 7 very specific reasons why it would stay in a plasma state, and we're going to go through every single one.
Okay, reason number 1. The fundamental force holding it together is just weak, really weak. You know how in our world the electric charge acts like a super strong magnet, snapping positive and negative particles together to make atoms? Well, the dark electric charge is more like one of those flimsy refrigerator magnets. It's up to 1,000,000 times weaker. It just doesn't have the oomph to grab onto passing particles and lock them into a stable atomic hug. Second, it's not just that the magnets are weak. The space between them is full of junk. For every charged dark matter particle, the theory says there are about 5.5 neutral ones just floating around. So imagine trying to get your 2 weak little magnets to stick together, but the air between them is filled with styrofoam peanuts. These neutral particles act like a fog, physically getting in the way and smothering the already pathetic attraction between the charged particles.
Reason number 3 is heat. The model suggests the dark sector is actually hotter than ours. And what is heat? It's just motion. These dark particles are absolutely buzzing with energy, zipping around like crazy. So even if 2 oppositely charged particles get close enough to feel that tiny tug of attraction, they're moving so fast and so violently that they just ricochet off each other. They're way too energetic to settle down and form a stable bond.
Now, number 4 is where things get a little weird. Not everything in this dark soup is the same temperature. The heavier dark protons, they're like little cast iron skillets. They cool off really fast. But the lightweight dark electrons are more like the air. They hold on to their heat. This creates what's called a non-thermal plasma, with cold, slow-moving positive particles mixed with hot, zippy negative ones. It's like trying to get a tortoise to dance with a hummingbird. They're totally different energies, and speeds naturally drives them apart, not together.
5th on the list is density, or rather the lack of it. Dark matter is incredibly spread out. The particles are just far apart from each other. Think of a few people scattered across a giant empty football stadium. They're way too far apart to be bumping into each other. So the only way they really interact is through that long-distance electrical push and pull. And here's the thing. A state of matter where particles are governed by long-range forces instead of short-range collisions is, by definition, a plasma.
Okay, reason number 6. This one feels a little counterintuitive at first, but the particles are also moving really, really slowly on average. So not only are they incredibly far apart, but they're just lazily drifting through space. The combination of low density and low velocity means the chance of 2 particles just happening to collide in the right way to form a bond is practically 0. They just serenely float right past each other.
And the 7th and final reason is basically the clincher: collective behavior. See, you don't even need all the particles to be charged for the whole cloud to behave like a plasma. Even if only 1% of them are charged, it's enough. It's like putting a few steel ball bearings into a big vat of molasses, along with a bunch of glass marbles. When you move those steel balls with a magnet, the thick, sticky molasses drags all the neutral glass marbles right along with them.
The charged particles respond to cosmic forces, and they pull the whole medium along for the ride. That collective movement is the ultimate signature of a plasma.
Whew! Okay, so you add all those 7 reasons up, and you get a very strong case for why this dark Earth would be a plasma. So now let's move on to the next question. What would this giant ball of plasma actually look like? It wouldn't just be a chaotic mess. It would have a structure, thanks to a force we're all very familiar with: gravity. The process that gives it structure is called gravitational stratification, and honestly, you see this all the time. It's why oil floats on top of vinegar in salad dressing. It's why the heavy stuff, like iron, sank to form the Earth's core, while the light stuff floated to become the crust and atmosphere. In any fluid or a plasma, gravity is going to sort everything out by weight.
And what's cool is, this isn't just a guess. A lab experiment by a researcher named Tellez actually demonstrated this. He had a fluid with charged particles, and sure enough, the heavy positive particles sank to the bottom, while the light negative ones formed a cloud on top. The dark Earth model suggests the exact same thing happens on a planetary scale. The heavy positive dark protons sink to form a core, the E+ region, and the light negative dark electrons form a huge fluffy shell around it, the E- region.
So what you end up with is a planet that is fundamentally polarized. You've got this dense positive core surrounded by a vast, diffuse, negative shell. And that sea of neutral particles we talked about? It acts as an insulator between them. What this means is that the dark Earth basically becomes a gigantic, naturally formed cosmic battery or a capacitor, storing enormous amounts of energy.
But the structure doesn't stop there. It actually gets even weirder. See, plasma has this amazing ability to organize itself into even more complex shapes. It's not just a simple core and shell.
Within a plasma, something called double layers can spontaneously form. You can think of them as invisible, self-generating energy walls. If you have 2 regions of plasma right next to each other, but they have different temperatures or densities, a double layer will just pop into existence between them to keep them electrically separate. Plasma builds its own containers.
Now imagine that on the scale of a planet. A whole series of these double layers that form, creating shell after shell after shell, each one nested inside the other with slightly different properties. The result wouldn't be a simple planet, but a kind of celestial onion with countless layers extending out into space.
And here's where the theory connects to things we can actually see. The author points to some elliptical galaxies that have these faint, visible shells around them. Now, the standard explanation is that these are leftovers from galactic mergers. But Alfred proposes a totally different idea. What if what we're seeing is regular matter that has been gravitationally pulled into the shape of an underlying, invisible, dark plasma onion?
Okay, that brings us to the final part, and maybe the most staggering one: the sheer scale of this thing. If this dark Earth exists, just how big is our invisible neighbor?
Well, based on work by the physicist Stephen Adler, who studied weird anomalies in the orbits of our satellites, the density of this dark matter seems to peak at a distance of about 70,000 kilometers from the center of the Earth. And that peak is what would effectively mark the outer boundary of this dark Earth structure, specifically that big negative electron shell.
Now let that number really sink in for a second. Our rocky planet has a radius of about 6,400 kilometers. This dark Earth has a radius of 70,000 kilometers. That means our invisible twin isn't a twin at all. It's a giant. It is more than 10 times the diameter of our world, which makes it roughly the size of Jupiter. We are, according to this theory, living completely inside a ghost planet the size of the largest world in our solar system. And really, that's the whole point, isn't it? This theory paints a picture of a universe that is so much stranger, so much more complex than what our eyes can see. It suggests our entire world is just a small kernel inside an invisible plasma giant. And if a world on that scale can exist right here, right under our noses, totally undetected, it just forces you to wonder, what else might we be missing?